Hello, in this video I'll go over the use of the OASIS-DEV deck and developer box. And in this case in a lab setting. It looks kind of cramped here, but I want to show you what we have here. First, here we have the dev box, and I already removed the cover that would normally sit on there if you're using it on a dock or a boat. Sonar transducer is hooked up here to the TX1 low frequency channel. That's also the broadband receiver, and here's the sonar transducer itself. Here we have a power adapter that's shipped with it that comes with, you can set the voltages to get more or less transmit power. Right now it's at 12 volts. This one here is one of those MSP-fed JTAG debugging adapters, so you can download code, and then I have an oscilloscope set up here. Right now, let's say we develop maybe some code for a new acoustic waveform and we want to check it out. So I hooked up the oscilloscope here on connector P11 and pin 11 on this connector, so P11 pin 11 here is the TX1 signal, so literally the signal that goes to the sonar transducer, but it's attenuated by a factor of 100 because you know, we might get several hundred volts output voltage there. Let's say we're testing a new waveform. Let's say I already downloaded a new app, and I'll launch it now here. Okay, here we go. Let's do a brief test of the sonar transducer in receive mode. Notice here the average at -71.2, and then if I click against the transducer, it should go up substantially, and you see that here into the 50s. I can probably get it to go much higher even, you know. It doesn't go that much higher with the clicking noise, but so the sonar transducer certainly seems to work in receive mode. So I will exit this here, and now I'll set up my oscilloscope. I'll stop this here for a while, the recording. Okay, I'm back, and I got all my stuff here configured for a transmit test. So I go to ping sequence test. Oh, wrong context here. We'll transmit at 34,000 hertz. Ping step, that means do we change the frequency of the pings for each step? I say no, 0. We'll make a very short pulse, just 400 microseconds long. The ping interval I'll set to 100,000 microseconds, so 10 pings per second. And here we go 10 pings per second. We'll transmit 50 at a time before it takes a short break and does it again. Okay, so now we see the result here on the oscilloscope. I don't know, maybe you can hear the clicking. I can hear the clicking of the transducer. When we look at the oscilloscope, our vertical scale right now is set to 2 volts per division here, and we are seeing about a little bit over 4 divisions, so a little bit over 8 volts, and this 1 in 100 attenuator, so that's really 800 volts. Now you can see how the amplitude gets less, and then finally the ping stops here. Let me adjust this slightly. Okay, and then we see here the end of the ping. So the reason why the amplitude gets less is because the capacitor gets discharged and the power supply can't keep up with it. So the momentary power actually exceeds what the power supply can do. This is now with a 12 volt setting on our power supply, and so you can adjust that here. Let me go down maybe to 9 volts now. You can see the waveform has a lesser amplitude, 7.5 volts, lesser amplitude yet, 6 volts gets to be very small here, and 5 volt we may have a hard time picking it up. No, it's still there. So what that means is you can actually sort of test with different source power levels. Let me go back to 12 volt. That is the maximum recommended voltage, and that's what we're testing with at Desert Star in our factory tests here. Now, if you want, you can go to greater voltages, 13.5, but it's not guaranteed to always work. It could exceed the capabilities of the EM60, and it might reset on you, but I set it to 13.5 volt now, and now we're getting a bit over 1,000 volt peak to peak here. I can even go to 15 volt, and that's the absolute maximum that you can do. Now we're at 1,200 volt peak to peak. The board is only rated for 16 volts maximum supply voltage. The power adapter has a 19.5 and 24 volt setting. I won't go there because you might damage the board. So I'm going back to 12 volts now. And there we go. I'll end the ping test by just hitting a key. Now I'm going to show you how to install a new code via a JTAG to the DEC box, and notice here is our JTAG module hooked up via this ribbon cable to the EM60 in the DEC box. Let's assume I already made my code changes here. I can go to Project, here we go, rebuild the project. Here we see the rebuild progress down here. And now the rebuild is finished. There's still something happening here. Let's wait a moment. Alright, now we have the build finished marking here. With the build finished, we now start the download via the JTAG debugger here, or JTAG interface. Run. Start debugging. Once code is getting transferred, you will see these LEDs blink here. Now the debugging session is finished. We're stopping at the main line. I will let it run now. Some blinking going on our LEDs over there, and now the application started, and I can get a help menu, for example. Here we go. Alright, so one problem is after you installed a new app, the bootloader will be gone, which means you couldn't install firmware in the field anymore. So how do you restore the bootloader? And it's really quite straightforward. You would go to Run, right click, I guess. Here we go, finally. Load program. Then you need to select the sorry, not the workspace. Again, just go to browse, and you have to find your file. We'll put that up online. I don't know quite where yet, but we'll put it up online. Maybe you can ask Orca, our AI, where to find it. And it's a hex file, bootloader em60.hex. See that here? And you hit open, and then hit OK. And now the download action started and completed already. So now that the bootloader has been loaded again, we can run it. Actually, all we have to do is hit this button here, and here we now see bootloader is starting. Application will start in 30 seconds. Another way to start it is actually that you can just disconnect all power from the EM60. You'll have to keep it off power for a few seconds, maybe 30 seconds, to allow capacitors to discharge, and then you just can plug it in, you know, again, and it'll start running. What you'll see is after you install the bootloader, the application will be gone. It says app starts now, no app installed. Hit Z to reboot, and now what you would typically do is reinstall your application through DSS update, that is through the USB port, and that will then allow you to have both the bootloader and the app on the EM60 for use in the field. So let's install our test application now through DSS update. You'll notice here that I already removed the JTAG dongle, so the updating will go through the USB port here. In DSS update, the first thing I have to do is select my serial port. And it doesn't let me do it right now. Well, that's because I have TerraTerm running, so let me kill TerraTerm. I don't know if it comes back automatically. No, it doesn't. So let me just launch restart DSS update here, just a moment. Okay, so now communication. Now we should be able to open COM15, which is the USB port leading to the developer box. And I'm going to go to show raw communications so I can see the data flowing back and forth here. And I'm going to do action, update firmware. And now I have to select my app. No, that's not the right folder here. Just a moment. EM60 test, debug. And here is the file. That needs to be a .s19 file, which is automatically generated by CCS if you have the right settings for it. You have to enable the hex maker or something like that, hex utility, to generate this file. We'll open this now. Now here the DSS update got the EM60 into the bootloader, and now the firmware upload is starting. And I'll pause it here until we are close to the end. Alright, we're coming up to 100%. And Now the upload here is done, and the application will start in 30 seconds. So now we are back in Terraterm. This app runs again at 115,200 baud compared to 9,600 baud for the bootloader. And if I do my question mark, then I get the help menu. So everything is fine. If I reboot the EM60, it should first go into the bootloader. You should see a little red double blink here. Let's give this a try. Here it says rebooting. It was hard to see the the LED blinking here, but now after it's in the bootloader, and it will stay in there for 30 seconds, and then it should pass control to the application. So we should get the startup message here. We'll just wait for that for a few seconds. All right, and there we see it. Self-test is running again after passing through the bootloader. So we have both of them installed. So that's the end of this video. So I hope you have a decent idea how to use this thing in the lab. Using it in the field is much easier, of course. No, not so much stuff going on. Put the cover on. You can still see the status LED through this window here, and that protects it a little bit from the elements. Thank you very much.